All right, team, let's make a game. So we're in Godot, and we have absolutely no idea what we're doing. There's nowhere to start because we don't have an idea. We have no plan. We could do exploratory coding, but that's not how you make a game. That's how you make a tech demo. Maybe that's a great place to start. We'll talk about the difference between games and tech demos. Games will generally have an objective, some kind of obstacle, something stopping you from reaching that goal, and some way to win or lose, some scoring system of some kind. If we look at games like soccer, the objective is to get the ball in the net. If the only thing to do was to put the ball in the net however you see fit, that's not a game, that's a chore. It's not interesting. The other guy is trying to stop you, being forced to use only your feet and your face, that's a game. So what I see a lot is people follow tutorials, they figure out a couple of mechanics, they get like a Minecraft clone going where they can pick up a block and put a block down, but that's not a game. That's a tech demo. You are demonstrating some mechanic without the context of a game. If you want to be a game developer, you need to think about your game first. What is the format, the structure that is going to make it more than a tech demo? So what we're going to make is Pong. For those of you that somehow might not know what Pong is, there are two lines, and then there's a ball. The ball bounces back and forth across the screen, and you move your little paddles, they're called paddles, up and down to intercept it and bounce it back at your opponent. This is a very famous video game. It has an objective, score on the other guy. It has an obstacle, the other guy. It's got win and lose conditions because you can get scoring. So, Pong is not interesting enough because it is explored space. We know how it works. We want to explore new things to keep us interested in our own projects. It's absolutely crucial for somebody like me to do something more than what we already know. So what we're actually going to do is not Pong. We're going to do wrong. And what we're going to do is every time that the ball hits the paddle, we're going to invert the controls. So up and down, we're going to say W and S will be up and down. And when you hit the paddle, it'll invert. So S will be up and W will be down. This is purely to demonstrate the process and because it sounds kind of silly and I kind of want to see how it works out. This is an extremely simple game, but it's going to allow us to talk about all the parts of planning and executing features that we don't know how to do. Because right now, I don't know how I would build this game. I wouldn't know how I'd invert controls. I have some idea of collision shapes and like how to move things, but those might not be the appropriate solution for what this is. We're going to find that out as we go. So I want to talk about planning a game. When you plan a game, you want to be as detailed as you can be, but you don't want to lock yourself into a corner. Things change. You learn about your game through development, and you get better ideas as you fill out the space. There's a really good GDC talk from a producer that says that her job is reducing ambiguity at the right times and with the right people. So she makes sure that nobody has to know the exact details of anything until it's actually time. And then she makes sure that those people do make those decisions so that nobody's depending on them and getting blocked. This is way harder than it sounds because we start out in the realm of infinite possibility and overscoping. And then we have to funnel it down into something concrete that we can type into the friggin' computer. Little tangent here, we're going to talk about overscoping versus scope creep. So overscoping would be adding a crafting mechanic to this game. That is from the beginning, we have this big idea and we make it bigger than it either needs to be or than we can make. That is overscoping the game of wrong. Scope creep is what happens later in development. When we're like, oh, we're inverting controls. We can actually just make it any button on the keyboard. Wouldn't that be cool? And yes, it would be cool, and yes, we are going to do it. But 3 or 4, 5, 10, 100 of these little wouldn't it be cools, and you never finish your game. Your scope creeps and bleeds out until it's something bigger than you can actually manage. Overscoping at the beginning, scope creep once you've been working for a while and you're like, we could expand these edges. You want to go in with a plan and know when your game is done. because you're going to make more than one game. You are a game developer, and game developers don't make one game. So, how much ambiguity in the initial draft of a game design document? For wrong, the only important things are that we have paddles, a ball, and invert controls. This is sufficient for an initial game design document for this game. If I was doing an RPG, for example, I might have some classes written down, or an idea of 3 classes that I want, or I want magic to be able to set things on fire. Any mechanic that I know I'm going to want, anything that I know I need to do, goes into the initial game design document. And this will generally be missing win condition, that sort of thing. That's why we'll do a second pass once we have all the requisite ideas down. When we know what our game is going to depend on, how things are going to interact, what's going to make it fun, we'll go back through and we'll think about making an objective, obstacles, win-lose conditions. So if I want to talk about scoring, is it just 1 point and 1 point if the ball goes in? Honestly, for this game, I think so. But for other games, like if you're making an RPG, you have to think about, can the player die? Do they go back to town? Are there checkpoints? Are they trying to clear a story? Or are they doing procedural content? The 3 really major important parts of a game design document before you ever start are the format, which are these 3 things, a screen mock-up, some idea of what one frame of the game will look like, including UI and any kind of effects or information. It doesn't have to be accurate, but you need to know the perspective of your game. You know what the camera looks like, how big the character is. All of this is going to allow you to start working on the game. So that's why I doodled this right here, because we need to know what it is we're building. So we've got the format, a screenshot, and then finally a list of unknowns, things that we have to investigate or prototype to see if they're fun at all, to see if it works cohesively together. Anything that we might discuss with the team or spend some amount of time actually digging into before doing, we want to make a list of those so that we can prioritize them. So for wrong, we don't know how to invert controls. We really have no idea how to do this. And so that's going to be our one big thing that we need to prototype, figure out before we ever try to introduce it to the actual game. So the level of ambiguity can actually be quite high. We only need to define things that we need to define. And figuring out what to write down now and what to leave open-ended is part of the skill of development and planning. I would say don't write yourself into a corner, but you also need to get out of the realm of infinite possibility and make some decisions. You never want to be in a scenario where you're working on a feature because the document says that it needs that feature. You don't want to be following a to-do list of, okay, well, we initially said that there are going to be microtransaction hats, so now I need to make the microtransaction hats. What you want to do is get to the point where you're adding hats, and that feels right. It fits the game, it fits the style, it's not intrusive in any way, and it supports the rest of the systems that make the game. Now, something you've probably heard before, but nobody ever elaborates on, and I really wish they would, is called Git. You've probably heard of GitHub, GitLab, maybe Codeberg if you've got big cojones. And there's a very important distinction here. Okay, so Git is the technology. This is the thing that all of these interact with and host. These are not necessary or important. I don't care if you use GitHub, GitLab, or Codeberg. GitHub is owned by Microsoft, and that is a big ethical and technical problem for lots of reasons. GitLab is where all the GitHub guys fled when Microsoft took over. Codeberg really aims to be more proper open source. It's not really a private repo, remote backup kind of place. So if you're on Codeberg, you should be doing actual open source where everyone contributes to your project, that sort of thing. Git is version control. I am not going to go in depth on Git in this series. There's just way better resources out there for learning Git. It does not take long. It's like 4 or 5 commands, and I will explain it briefly right now, but get the information elsewhere. What version control does is it tracks the changes to a file. So if I have a file that says ABC and I check it into version control, and then I modify it to say, I don't know, ABB, and then I check it into version control, what it actually checks in is this change, just this one line of change. And what this means is that I can go back to this version anytime I want. It also keeps file sizes small while backing up virtually everything. It is not a proper backup system. Proper backups are not on your computer. They're not even at your home. They need to be remote because your house can get set on fire. You should have a backup strategy and a version control strategy. For our purposes, this is going to allow us to do kind of like save states and emulators where we can say, okay, this is the point in the project I want to save everything. Now I'm going to go do some crazy stuff. And if it messes up and I totally bork the entire project, I can simply return to the last known working condition. What Git also lets you do is branches. So if I want to work on adding multiplayer, for example, I can do it on this branch. And then I can continue developing the base game here. And at some point in the future, I can take this branch and merge it into this branch. And what Git does is it compares the differences between files to make it possible to simply update everything that you haven't touched on this branch to what this branch has. And then you can manually merge the stuff that you have changed on both and get the new line made from both of them. Continue development. And then maybe you add some more features, like I want to add hats. So you have a branch for that. And I want to add chairs, and you have a branch for that. And they can all merge back in to the main line of Git. So generally, you have a branch called master or main. People are trying to change this because slavery connotations. And this is the main working stable branch of your development. This is the thing that you will send to people when they ask you about your project. This is what you can answer questions about. This will not change. This is permanent. This is forever. We also have the development branch, generally called dev. Now, this is the branch on which you work. Everything goes to dev while you're working on a new version. And then when that new version is complete, you send it all up to master. So dev might have many feature branches under it, right? You might have hats and multiplayer. And these are all independent copies of the entire source code. They're independent copies of the entire game, but this one has the multiplayer changes. This one has the hats changes. This one has all the working changes. So when hats becomes viable, when you're sure that this is code you're going to keep, you send that up to dev. When multiplayer is done and it's working, you send that up to dev. When the whole thing is at a good, stable point where you're not going back and you're not changing any of that code, and you're sure of it, that is when you send that up to master. For a solo developer, this is probably needlessly complicated. You're not going to use branches that much as a solo because you're only working on one thing at a time, really. But if you were working on a team, imagine that you had different people working on hats and multiplayer. They could both do their work at the same time on the same files and then merge them into dev, where a project manager could review their code before sending it up to master or main. That is the power of Git. Git allows many people to work on the same files, but it's very good for solo devs too. I'm going to explain why in this part that everyone skips all the time. When you're working on Git and you do some work, you then do what's called a commit. This is where you save changes to the branch that you're on. So you say, I've changed 4 files. This is why I changed them. And this is a new save point on the branch. So when you do that, you have to make a commit message. And you might say, fix that bug in hats.gd. So along with this save file, right, where you say, this is the point at which we're saving, you put a message with it. So everyone knows that if they return to this section right here, they know that this is where that fix came in. So if it's a bad fix, they can undo it. Or if they need to see how you fixed it, they can actually see all the differences in the code that you made. And this gives you a very convenient and good working history for everything that you're doing. But it also encourages you to make small changes that are on purpose and do something useful. Right? If this whole commit is just fix the infinite loop, then when you sat down, you might have changed 50 files to figure out how to fix the infinite loop. But the only code that you're committing is the fix. It's just that one small change that you can talk about and say, yes, I did something useful. over time, as a solo developer, you'll be able to run git log, and it will just have a list of your commits after commit, after commit, after commit, and each one will have a message saying that you did something useful, and this is unbelievably satisfying. You will get to the point where this is gamified, and your whole day is just about making as many commits as possible. It just makes development fun. I know that's a silly thing to say in a technical video, but it just makes development fun, safer, better. It's backed up, you're version controlled, you can work with other people. Git is amazing. Use it. Seriously, don't sleep on it. Okay, so to make this make more sense, I just kind of wanted to show you guys a repo. This is not my repo. This is a repo for a project that I like, that I use. Repo is short for repository. It just means the collection of code that Git keeps and that we upload online. What we can see here is up here in the top left, we've got branches. So we've got master, we've got fixed range again, flatpak flag. These are different features that they're working on. But if I want the currently supported working version, I go to master. So in here is all the source code, all the files that make up the project. I believe this one is only like one file, Anigly. But I can click it and I can see the source code, and that's great. I can see pull requests, which is code that people have sent up and asked to be merged into the master branch. So these are things that people have fixed and submitted their fixes, and they're waiting on the big boss man to merge it in. If we go to here, we can see 785 commits. So this has been in progress for quite some time. And we're just going to read some of their commits to see what kind of granularity you should have. So this guy edited the docs, added a Claude kill string to the README in hopes of deterring vibe coders. If we click that, we can see exactly what those changes are. So he added 5 lines to this project. If we scroll down, we can see fix dmenu feature was half-baked. And then we can go in and we can see what code they changed specifically. And you can see there's not a ton of code. There's not 30 files. This is one file that has been fixed up. And that's it. That's all we're looking for with each commit, is a couple of lines of code that do something important. So I think we're about ready to get into the actual Godot. Just to recap everything that we just talked about. Games versus tech demos, they need an objective, an obstacle, and a win-lose condition. We're going to make a Pong clone named Wrong, where your buttons invert every time it hits the paddle. Overscoping versus scope creep. Overscoping is at the beginning, and scope creep is over time. Git allows us to save our progress along branches as we develop, and encourages us into a very focused workflow. This is going to be critical for us. For unknowns, the only thing we listed was inverting controls, so let's figure out inverting controls together. Very first thing we're going to do is figure out what that means, which I think is just W and S are going to be up and down, and we want to flip them. This seems very trivial in our little example of a very simple game, but extrapolate it out to your dream game. If you want to make an RPG and you want to throw a fireball and have everyone in the area take damage, you need to figure out exactly what that means before you can do anything. Does that mean just the enemies? Does that mean the enemies and the players? Does that mean allies? Does that mean, is that area two-dimensional or is it a sphere? How does it actually work by design? Figure that out on paper before we go to coding, and you will save yourself a ton of time and heartache. You need to know exactly what you want to code before you can code. So the very first thing I would do in this situation is probably go for Godot remapping input. First result seems good enough. Now I'm going to scroll through here pretty quickly because I don't know if this is a quality thing or not. And what I'm looking for is some hint as to what to look for in the documentation. I could just go to the input function, but maybe there's something I don't know. And this is like a reasonable way to start. We're just looking for things to hook into at this particular point. So we're looking for where he actually remaps the button. Okay, so we scroll down and we can see here, input map, action erase event, input map, action add event. Now that is as much of tutorial or Googling that I'm going to do now that I know what I'm looking for and it exists. So we're going to go to the input map in the Godot documentation. And the two things that he used were add action and erase action. So let's open those up. Add action adds an empty action to the input map with a configurable dead zone. An input event can then be added to this action with add action event. Erase action removes an action from the input map. So that's probably going to be less helpful for us. But add action event sounds pretty relevant, so we'll go there. Adds an input event to an action. This input event will trigger the action. We don't know exactly how we're going to use this right now, but we know that it's at least in this ballpark that we're going to need to mess with. And this is a later thing. It's like the last thing we need to do for our game idea, but it's the only thing that we had no idea where to even start. It was on our list of unknown. If it's something where we're just lacking research and knowledge like this, we look it up. If it's something that we don't know if it's going to be fun, then we prototype it with cubes and we see if we can make it fun in a test project, not in our main project. So for our unknowns, we know that we need to go into the input map. We'll put add and remove action there, and that is not hard-coded. That's not super important. It's just there to remind us what we looked at and what we kind of learned from our research. All right, so we have figured out our unknowns. At least we've got some kind of a starting place. We have some idea of how hard it's going to be to do that, which is not very hard in Godot. So the next thing we need to do is start thinking in dependencies, which is we look at our screenshot and we just kind of think through what needs to exist for that screenshot to exist. And I'm not talking about character models or fancy graphics or anything like that. I'm talking about in our screenshot that we've doodled, there are two paddles and a ball moving. So we need two paddles for sure. We need the ball, but more than that, we also need some kind of zone outside of the paddles that says when you've scored. So we're going to call that the end zone, and we can kind of break this down more if we want to. And this is the appropriate amount of ambiguity to have at this stage. We know that the paddles are going to need collision, and we know that one's going to need AI to move up and down, but that is too nitty-gritty for what we're doing here. You always want to keep things at the same resolution, so you're never going super detailed on one thing and not very detailed on another. You want to work in layers so that you're getting deeper and deeper as you go. And finally, I think that for this game to work, we really need a fixed camera. I think it's going to be kind of important because showing that this is the edge of the screen is pretty important. It doesn't move anywhere. So having a fixed camera is probably pretty important. So with this in mind, now we can actually do some work because we know what it is we're building.